All right, now let's look at question 2 of the very same question paper, Gauteng, right? 2025 prelim. It says the letters A to F in the table below represent 6 organic compounds, okay? So I like first by analyzing which one is which one is which, so that when I answer questions, everything is beautiful. So here I have CH3, okay, CH2, and then C double bond O, CH3. Since well this one has a double bond O, remember there are two compounds, or rather there are two homologous series that has double bond O. Okay, the first one it is aldehyde, the second one it is ketone. But I know aldehyde has a double bond O at the terminal carbon. Again, at the terminal carbon. But this one has now double bond O between these two carbons. So this one is a ketone, and the ketone has a group of carbonyl, carboxy, what is this? A functional group of carbonyl, and then CH3CH, CH3C, H2CH3. Okay, let's try to visualize this. This represents a branch, but let's try to see that CH3. So it's gonna be CH3, right? CH, and then they tell you that this is CH3. So can you see this is a branch thereof? So I can say CH3 like this so that you see it, and then CH2, CH3. Can you see that my longest chain it is here? So yeah, this is just an alkane with a branch. This is here CH2Br. Okay, this is an Br, CH2, CH, Cl2, CH3, CH, blah 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 blah. So my longest chain is gonna go like this. It's either go down or up, either way. So this will be my branch, my substituent, my substituent. So this one is just haloalkane because I have halogen as well as hydrogens. This one CH3COOH, I know this is carboxylic acid. The one with COOH, it is carboxylic acid, and its name is easy. Okay, not necessarily easy, but I can say this is, since well this is and this is CH3, I can say this is methanoate. Methanoate. I'm thinking, and then remember it is a carboxylic acid, and functional group it is carboxyl. And remember when I mix this with alcohol, it gives me an ester. Ethine, ine. It is an what? It is an alkyne. Remember it has carbon-carbon triple bond. Actually, it's like this one. Ethine. Aye. Then CH3, CH2, CH, OH. This is an alcohol. 1, 2, 3, 4. Okay. 1, 2, 3, 4. Remember, I try to name from where my substituent or my OH, my functional group, has the shortest. Again, because if this is 1, 2, 3, it is 3. So I prefer 2 than 3. So this one is just my alcohol, and it has a functional group of hydroxide, and it goes by the name of 1, 2. So I think it's gonna be longest chain but is gonna be butane. On position number 2, I found an alcohol, butane to all, because it is alcohol. Now, 2.1, name the homologous series to which each of the following compounds belong. Can you see now? I think I'm gonna run smoothly here. A ketone, A ketone, C haloalkane. Oh my god. Or someone might say haloalide. Okay, haloalkane or haloalide, alkyl halide. Aibo. What do they refer to this? Haloalide or alkyl halide. But yeah, I think it is alkyl halide. But just stick with what is this? Haloalkane is just easy. Write down the IUPAC name of C. What is C? What is C? What is C? So let's name the IUPAC name here. So first carbon, second carbon, third carbon, fourth carbon, fifth carbon. So I'm gonna take my longest chain like this. Okay, so it's either start naming from start counting my longest chain from here or from here. Let me start from here. It is 1, 2, 3, 4, 5. Let's see. If I do that, bromine is number 1. So I have 1 bromo, and then chlorine is number 3, 3 chloro, and then number 4 I have a methyl group. Okay, can you see this is a substituent? That it does not form part of the longest chain. So I can say 4 methyl, longest chain 1, 2, 3, 4, 5, methyl pentane. Okay, I can say 1 bromo 3 chloro 4 methyl pentane. Or if someone starts naming from here, it is 1, 2, 3, 4, 5. I want you to see something. When you do that, you're gonna have, remember, alphabetical order, it is very important. B comes before C and C comes before M. It's very, very important. If you have dimethyl, you do not consider the di because the di just tells you how many of them. So dimethyl does not come before uh, whatever. So when you consider naming di, you do not take it, you do not consider it as an alphabetical order as such. Okay, yes. And then what I wanted, okay, if we do it like this, it's gonna be B is gonna be number 5. So it's gonna be 5 bromo. I want you to show you why this is wrong. 5 bromo chlorine number 3. And then what is this? This is number 2. Methyl what? Pentane. What's wrong here is that, remember, when we try to count when we count here, we try to count such that this number here, it is the smallest possible. The sum of these numbers, it is small. 1 plus 3 plus 4, the sum here it is 8, the sum of the position. Here the sum it is 5 plus 3 plus 2. So can you see that the sum here it is 10? So we prefer taking this one with the smallest sum. So this is incorrect. I hope that's clear, guys. One of the mistakes that many learners do, but I think I have clarified it. 2.3 says write down the letter of the compound that has a carbonyl group. I go to my graph. I think I analyze carbonyl group. A. Can you see, guys, the beauty of analyzing before you go to your questions? The beauty of doing what? Of analyzing. Then they say to me, write down the structural formula. Structural formula, remember, it is the one that where you draw for the functional isomer of compound A. I need to look at compound A. Compound A is ketone. What is the functional group? So functional isomer of ketone. It is what is this? Aldehyde. Why? Remember, I said carbonyl has what? Has double bond between carbon atoms. Okay, but this is ketone. But aldehyde has a what? Has a double bond. I want to see when I use 3. This is H. Can you see? They both have what? O. They both have O. But this one, it has an O at the middle of the carbons. This one has an O in a terminal, or the first or the last carbon. So these are functional isomers. Why? Because when I change this double bond O here to the first position, it's no longer a ketone. It's now an aldehyde. So hence it is not a positional isomer, but what? A functional isomer. Okay. If it was a positional isomer, it means if I put it here, I'll still call it by ketone, but no, it changes the name or the function, the homologous series, all of it to what? To aldehyde. So yes, this is now the functional group of what? Of a functional isomer rather of what? Of ketone. So it has how many carbons? 1, 2, 3, 4. So I just need to draw an aldehyde with 4 carbons. 1, 2, 3, 4. Guys, when you draw, try to space out so that your thing is beautiful for the examiner to easily see. Remember, guys, don't forget an hydrogen. Double bond O H. This is an what? This is an aldehyde. but A, it is a what? It is a ketone. And they have the same general formula. Okay? The same general formula, CN, H2N, O2. O, general formula. 2.4.2, write down the structural, this is still 2.4, write down the structural formula for the ester when the same molecular formula as, okay. So write down the structural formula for the ester with the same molecular formula as D, compound D. Compound D, it is, what is this? Compound D, it is carboxylic acid, and we know that the functional group of, sorry, functional isomer of carboxylic acid, it is what? It is ester, okay? But now they want us to draw what? An ester with the same molecular formula. So the molecular formula for this one, if I were to do the molecular formula takes, it says how many C do I have? I have 2 C's. How many H do I have? I have 4 H's. How many O do I have? I have 2 O's. So they want me to draw an ester with this one. But what do I know? I know that the carboxylic acid has a Q at the end. Okay, but this is a what? Carboxylic acid. But an ester has a something double bond O at the middle, like this. Or I can take the oxygen on this side, however, and then this is still something, and then I still have something. Can you see? It has its COO in the middle. This one has a COO at the end, more or less similar to ketone and aldehyde. So it's easy, guys. You just need to draw that has 2 carbons, an ester that has 2 carbons, an ester that has 2 carbons. I can say this is O, C, okay, an ester. So remember, an ester, it is composed of what? It is composed of alcohol as well as carboxylic acid. So this is the carboxylic acid part, okay? This is the alcohol part, okay? Or someone might start with carboxylic part, it's still fine. What's important is that you have the structural O in the middle, and then still the same thing, okay? Still the same thing. What's important is that the functional group of COH, this one, this part here, it is correct, and then everything else has a hydrogens, everything it is correct. Okay, guys, yes. So, yeah. Draw the structural formula, write down the structural formula of the tertiary alcohol of compound F. Tertiary alcohol of compound F. Compound F has how many carbons? 1, 2, 3, 4. So remember, you need to go back to a concept. What is a tertiary alcohol? It is a carbon. It is an alcohol. Okay, the carbon bonded to the hydroxyl group is bonded to other 3 carbon atoms. So the carbon bonded to the hydroxyl group, it is bonded to 3 other carbons. Another bond can come from where? Here. So this is what I'm required to draw. Since well, it has 4 what? It has 4 carbons. Guys, this is very beautiful. This is just an easy marks. This is just easy marks. Okay? Because now it says the carbon bonded to the hydroxyl group, or the OH, it is bonded to 3 other carbons. 1, 2, 3. What is wrong if I were to remove it here and put it here? Can you see now the carbon is bonded to this one and this one, but not directly to this one. Hence, it's wrong. So the most correct one, it is this one, guys. And I call this the king. The king is bonded to 3 other people. So this is it, guys. This is it, guys. Very beautiful. 2.6. Which one? Okay, which letter in the table above represents an unsaturated hydrocarbon? I know an unsaturated hydrocarbon, it is the one that has multiple bonds. Again, so the one with multiple bonds, it is alkene as well as alkyne. So let's go look for alkene or alkyne in our group. So in our table, I can see alkyne at number E, and I do not see an alkene. This one, it is saturated because it contains single bonds. Okay, so number E is the most correct answer for me. Number E, it is the most correct answer for me. The compound with the general formula CnH2nO. This one, CnH2nO, it has one alcohol, so one oxygen. So the one with one oxygen, remember I said ketone and what has one oxygen. So I can draw like this. Okay, how many carbons do I have? If I have two carbons, I need to double those carbon hydrogens to be 4 and then one O. So let me say I have H here, H here, H here, and then H here. I already have what? I already have 4 carbons. Can you see? Let me actually do carbons with a different thingy. 1, 2, 3. I can complete the other one here and say 4. But I still have this double bond here, or these single bonds waiting here. And I only have what? Oxygen. But remember, oxygen can accept 2. So it means this one I'm going to break it and make it what? Double bond, and then that is O. So this one, can you see? It's either what? It's either a ketone or an aldehyde. Okay, why? Because if even if I were to do this will just change here, C3 and oxygens thingies will be 4, like that. But I have to remove this so that it becomes 1, 2, 3, 4 bonds for that carbon bonded to oxygen, and then here have H, H, H. Can you see? There are 6, there are 3, and this can either be an aldehyde or a ketone. Aldehyde or a ketone, it is found where? Aldehyde or ketone, it is found on number A. A, it is aldehyde or ketone. Cool, guys. We are cruising nicely. Using molecular formula, remember guys, molecular formula is the one that says there are 2 carbons, 4 hydrogens. This one, there are 4 hydrogens, 4 carbons, 8 hydrogens, 2. This is molecular. This is general. This is general. This is molecular. So this is structural. This is condensed. Guys, you need to know this off by heart. Let's see. Write down the molecular formula for using molecular formula, write down the balanced chemical equation for the combustion of compound B in excess oxygen. Okay, this is a combustion again, and we know that for combustion we need an alkane and oxygen. So alkane, where do we find alkane? Number B. Okay, number B is an alkane. So we need to find the molecular. So we need to count the number of carbons. 1, 2, 3, 4, 5. So we have 5 carbons. How many hydrogens? 3, 4, 7, 10, 12. H12. So it is C5 reacting with excess oxygen. Guys, always, not sometimes, one arrow, one arrow. Always, not sometimes. The combustion reaction always results in the formation of carbon dioxide plus water. Guys, for you, okay, for you just correctly doing this, you have 1 mark for the reactants, 1 mark for the product. The other mark will come from balancing, for you knowing how to balance. If you don't know how to balance, it's not okay, but at least you have 2 out of 3 for writing these correctly. So let's try to balance. The number of carbons here, 5, here it is 1. And then remember, oxygen, it is the last one to or a balance. Try to do that. My trick is just I try to balance oxygen last. Let me go to hydrogens. There are 12 hydrogens here. There are 2 hydrogens here. So it means if I were to add 6 here, it's going to be 6 times 2. It is now 12, and it's 12. So balanced hydrogens, balanced carbons. Let's now consider our what? Let's now consider our oxygen. 5 times 12, sorry, 5 times 2, it is 10, plus 6 times 1, it is 6. So this is 16 on this other side. So here it is 2, so I need 8 here. So guys, this is balanced for 3 marks. Balanced for what? For 3 marks. For 3 marks, guys. Last question for this one, guys. This was an easy 21 marks. A compound is analyzed and found to have an empirical formula of CH2O. Okay. The molar mass of the compound is found to be 150 grams per mole. Okay. What is the molecular formula of the compound? Okay. Now, okay. Now we found that the molar mass of the compound is 150 grams per mole. Now let's try to find the molar mass of my empirical formula. It's going to be carbon, it is 12 plus 2, 1 hydrogen plus oxygen, it is 16. This results in something like 1430. And then I will need a ratio. A ratio is going to be this one, the one that you are given, the molar mass that you are given, 150, divide the one that you got, which is 30, and mathematically it says it's 5. Therefore, it means now your molecular formula needs now to be 5 times your what? Your empirical formula. Remember, your empirical formula tells you that it is the simplest whole number ratio. So they simplified that by dividing every element by 5 or atom by 5. So this yields to something like C5. So it's going to be C5 here, not 5C, C5. 2 times 2 times 5 is 10, guys. Why am I writing so bad? C5H10O5. This is now the formula for the molecular formula thereof. I think you get a mark here and then you get a mark here. I'm not sure, but yeah, just for 2 marks, you need to know how to do your thing thereof. I think a mark here and then the mark for your final answer thereof. Okay, so yeah, guys, let's move on to what we say it is now question number 3. Okay, physical properties. Sorry about that. Physical what? Physical properties, guys. So yes.